All right, so in this lesson, we're gonna learn how to do a two-sample. So it's a two-sample hypothesis test, but we've already done a two-sample hypothesis test of means. This is a two-sample variance comparison test. What do I mean by variance comparison? Well, different populations, populations don't always have the same variance. Remember that variance, sigma squared, is, can be a lot of different numbers. So the variance of a population could be like, 17, or let's say that the variance of the population is like 100, okay? So when you have two populations, like population A and population B, you want to know, well, are their variances similar? Is the variance of population A, kind of the same as the variance of population B? Or is the variance of population A very different than the variance of population B? Like if variance of population A is 17 and the variance of population B is 100, that's very different, okay? But what if the variance of population B was like, 16? Well, 17 and 16, they're very, they're kind of close, aren't they? So that's what we're trying to do here, and so I'm going to go through some steps on how to do this hypothesis test. So we're going to go through an example here with population A. Here's some data from population A. Here's some data, a sample from population B. This is not all of population A, it's just a sample. And this is not all of population B, it's just a sample. And we're going to use these samples from these two populations to go through the steps, okay? So the first thing you're going to do for a variance comparison test is you're going to identify the sample variance, S squared, and the sample size for each sample. So we're going to go over to Excel and we're going to enter the sample in for population A, and we're going to enter in this sample for population B. Okay, here we are in Excel, and I've gone ahead and I've entered all these values for population A, and then down here I've entered all the values for population B, and we need the variance from each one, okay? And so we're going to do descriptive statistics. We're going to go to data, we're going to go to data analysis, and we're going to select descriptive statistics. We're going to hit OK. Our input range is going to run from this number up to this number. We're going to hit enter. And then our output range, let's go ahead and put the output maybe right here. And then summary statistics, and we'll hit OK. And we're going to widen these columns here a little bit. And look, we can see there's the sample variance. Looks like it's 83.733333. 83. Okay, so for population A, and we're going to call this S squared sub A, is going to be 83.733333. Okay, great. And then the N, here's the count. The N is 16. So N equals 16. Okay. Now let's do the same thing for population B here. There's population B. We'll go to data. We'll go to data analysis, descriptive statistics. Input range, we're going to scroll down. We're going to use population B. So all these numbers will be our input. And then our output, we'll put it maybe right here. Okay, and then summary statistics, and then okay, and here we go. Sample variance is 192.183983. 183.983. Well, let's come back to it. 192. So this is going to be S squared. That's remember, that's the sample variance of population. The sample from population B is 192.183, and then 983. 983. Okay. Down here is our count, 22. So n is 22. All right, well, that's step one. Let's now move on to step two. Okay, so step two is the larger s squared, the larger s squared is called the numerator with degrees of freedom 1. And then the denominator, or the smaller s squared is called the denominator with df2. All right, so let's look at these. Which one's larger and which one's smaller? Well, 192 is larger than 83. So that means that the s squared, the variance from a, we're going to call this one the denominator, and the larger one, which is also going to be called df2, that's degrees of freedom 2. And then the variance from population B, from sample from population B, we're going to call that the numerator variance. There's good reason for this. Don't worry about it right now. It's all going to make sense in a few more steps. And we're going to call this df1. Okay, that's step two. All right, now let's move on to step three. All right, step three is state the null and alternative hypotheses. All right, so we know that the null hypothesis starts off as H sub O and that the alternative is going to be H sub A. And what are we comparing here? Well, our comparison is variance. So we used to put mu here, but we're not going to put mu here. We're going to put variance here. And what are we trying to compare? Well, we're trying to compare the variance from population A to the variance from population B. And what is our null hypothesis? Well, our null hypothesis is no difference, and that means equals. And then our alternative hypothesis is that the variance from population A is not equal to the variance of population B. Okay, this is going to be at every single time. It's going to be the same one every single time. The only thing that's going to change is you might not have A and B here. You might have different letters here. Okay. All right, so that's the null and alternative hypotheses. Now let's look at what step four is. In step four, we are going to identify the alpha, which we were not given yet, and we're going to state that it's an F-test. Whoa, hang on here, Mr. Ryan. You haven't told us about this one. We've done a Z test, we've done a T test. What in the world is an F test? Okay, well, an F test is just another distribution. Okay, one of the biggest differences with the F distribution is that the F distribution has no negatives. Okay, the F distribution is all positives, okay? And it has sort of a weird shape. Instead of being bell-shaped, it actually starts at the origin and has this weird sort of like this hump at the beginning, and then it levels off. That's what the F distribution looks like. And I know what you're thinking, Mr. Ryan, are you going to give us another one of those tables? No, we're actually going to use Excel to identify our F statistic. Okay, so we're gonna identify our alpha, and let's assume that that in this particular test, let's assume that we're doing an alpha of 0.05. Okay, 0.05. And then there's one other thing that you're going to do here. You're going to identify the DF1 and the DF2. What do you mean by DF1 and DF2? Well, remember degrees of freedom? Remember how degrees of freedom is equal to n minus 1? Well, that's what's happening here. DF1, look, here's population, our sample from population B is DF1. So we're going to identify DF1 based on n equals 22. And then DF2 will be identified based off of an n of 16. So because we have two samples from two populations, we have two n's. Therefore, we have two DFs. We have different degrees of freedom. All right, so our alpha is going to be 0.05. It's an F test. And then our DF1 is going to be, look, 22 minus 1. It's going to be 21. And our DF2 is going to be 16 minus 1, which is 15. All right, step 5 now is identify the critical F value, which we're going to call F crit, using Excel. All right, so here's how we're going to identify that, okay? In any cell, you're going to type in a particular command. All right, so you can see here, you're typing in equals, and then F period or dot, INV dot RT parenthesis, and then whatever your alpha value is, which for us right now is 0.05, comma, then your DF1, which for us is 21, comma, then your DF2, which for us is 15, and then a parenthesis, and then we're going to press enter. And then we're going to state the decision rule. And here's how this decision rule is going to go. We're going to write reject H sub O if F is greater than whatever the F crit number is. So we're not going to put the word F crit here. We're going to put the number that we get from Excel. We're going to say if F is greater than that number, then we would reject H sub O. Okay. All right. So let's go over to Excel and we'll put in 0.05. We're going to type this in. We're going to put in 0.05 and then 21 and then 15. Okay. So we're just going to select any cell. We're going to select this one right here. And we're going to type in equals F dot INV. And look, it's already predicting it. It's showing INV.RT. RT parenthesis 0.05 comma 21 comma 15, close the parenthesis and then press enter, and look at it, there it is. It's 2.316317, and we're just going to put 2.316. F crit equals 2.3, what did it say? 316. That's step 5. Now let's go on to the last step. We can't forget to write the decision rule, which is going to be reject H sub O if F is greater than 2.316. All right, the last step is step 6. And that is calculate the F statistic and make a decision. All right, the formula for calculating the F statistic is very easy. It's F is equal to the numerator S squared, which for us is, look, numerator down here. The S squared for the numerator is 192.183983 divided by the denominator S squared. And now finally we understand why we called them numerator and denominator, is because in the F statistic calculation, in the formula, it's just a fraction. It's a numerator divided by a denominator. We just divide one variance by another variance, and it's always the larger variance divided by the smaller variance. Because if we did the smaller variance divided by the larger variance, it would always be less than 1, and that doesn't make any sense, and you'll see why in just a little bit. Okay. All right. So here, if we're going to calculate our F, it's going to be F is equal to the numerator S squared is 192.183983 divided by the denominator is 83.73333. Okay, and now we're going to switch over to a calculator. All right, so here's the NumWorks calculator. We're going to go to the calculation, and we're going to do 192, 183, 983, 192.183, 983. So 983, 183, 190. Yep, divided by, and it's 83.733333. Okay. And so our F statistic is 2.295190. We're just going to say 2.295. So F is 2.295. Okay, and now we're going to make a decision. So here's our 2.295, and you can see that 2.295 is not greater than 2.361. Therefore, we are going to say do not reject H sub O. And so here's our conclusion, is we're going to assume that the variance of population A is no different than the variance of population B. And you may say, you know, Mr. Ryan, 192 is way bigger than 83. How can you not assume that they're different? Well, because our F statistic was not large enough to reject the null hypothesis. It needed to be larger than 2.316, okay? And that's something you can take up with science people over their requirements for being able to show that two variances are different. Okay. All right. So I'm going to end this lesson video here, but in the next video we're going to do two more examples of how to do a two-sample variance comparison hypothesis test.